$2 an hour down there to watch their websites on the thing, so I don't think she's gonna be watching them down there anyway. Okay. Now, distribute 2x cubed minus 4x plus 7x equals 9x plus 2x cubed. So, I don't know if you heard it in my voice, but when you first see a 2x cubed in an equation, your initial thought must be, God bless, your initial thought must be, what? I'm not used to seeing cubes in equations. In fact, in here, you're not used to seeing squares in equations. Now, we're going to spend probably the better part of a month learning how to do equations with squares in them. But cubes, we don't spend any time doing equations with cubes. But the really cool thing here is if I subtract 2x cubed from both sides, what happens? Yeah, they go die-die. Now, let's put it together here. This is 3x equals,
You messed up.
oh no, I did not. I did not mess up.
All the numbers are x's.
Okay, let's divide by 3.
What? I think.
And I get x equals 3x. Now, normally speaking, I would say that I can't think of any answers, but I actually can.
Is X 0? 1 0.
Not 1, 0. I told him?
-1.
Oh, no, not -1.
I mean, minus
I
1.
said I was
1 minus
confused.
1
She's
is
like, you
0,
do.
0 is the only answer. Now, let's go back and check. 0 times anything is 0 plus 0 equals 0 plus 0. So the answer would be a donut, okay? 0 it is, okay? You know, it's a very strange equation, but every now and then we do get strange equations and we can't panic in the face of weirdness, okay? Any questions? Okay.
Yeah. Really?
Ms. Congo, I'm really tempted to say this. Now, before I say it, let me say that I adore you. I think you're awesome. But remember how you said I never said that stuff about negatives and flipping the sign?
Mm-hmm.
You were having a very deep conversation with Emma, and had I said something, you would not have heard it.
Donut? What? What?
What I'm saying is that if I would have taught something new in the middle of your deep conversation with Emma, then you would have looked up and said, I never taught you that.
Oh.
Oh,
Donut.
Okay.
all right.
The point is you weren't paying attention. Now we're
Yes.
paying attention, and we should have been paying attention.
Bingo.
A donut.
Better said. Okay. Now, a poll shows that a candidate is projected to receive 57% of the votes if the margin for error is plus or minus 3%. So what that means is they're supposed to receive 57%, but when you actually figure out there's a little bit of error possible in the poll, it might be exactly right, but it could be as much as 3% less or 3% more. So if I'm 3% less than 57%, what percent is that? 54%, good. And if it's 3% more than 57%, what percent is that? 60%. Now, the first thing is that we would normally express our numbers as decimals, not as percent. It says here, write a compound inequality, and that's one of the things we're going to talk about today. Compound normally means more than one thing. For example, have you ever heard of a compound fracture?
No. Yes.
Okay, a compound fracture is not only is the bone broken, but the bone breaks through the skin.
Oh, yeah.
So you have, who did that?
I said I have heard of that.
You have what?
Heard of that.
Yes, exactly. And a compound fracture, though pretty rare, is two things wrong at once. When you make a compound in science, right, you're mixing two different things together, okay? So, or when you compound the problem, you make it even a bigger problem than it is. So, when we write a compound inequality, we're going to do more than one inequality at a time. Now, this says that they could receive anywhere from 54 to 60% of the votes. So the amount of votes you actually receive, X, is going to be between 0.57 and 0.60. And that would be a compound inequality. In other words, two inequalities at the same time. Kind of like the intervals we spoke of. Remember earlier in the year we would do this? Right? that would be it's an interval, but we could also look at it as a compound inequality, okay? So in this case, it's a bounded interval between, if you're supposed to get 57% and there's a margin of error of 3%, you'll be between 54 and 60%. Oh, I wrote 57 here, I'm sorry. Should be 54, okay? So it's between 0.54 and 0.60. Any questions? Preguntas? Okay. Let's go to the next part here. It's time to tackle one of the algebra problem types that often frustrates students. We're going to spend many days doing this, so let's get rocking. The classic inequality problem. Okay, now, solve that inequality. Should be pretty easy. Somebody call me? Oh, over there. What? What's in the back room?
Just supply, the supply.
My refrigerator? Supplies. It's a small fridge.
So it's mini.
Yeah.
You would say.
You should get a full size.
Like if it's a
Full chip and veggies.
if it's a small fridge on if it's a small item on occasion, I wouldn't mind at all. But there literally is not that much room in the fridge. It's one of them like
Minnie, let's take a field trip to go see. I want a mini fridge.
cheese.
That's not
All right. I don't know. Let's see. Okay. So if I'm going to solve this guy, it should be pretty easy. Minus 10 minus 10. Die. 5q is greater than 10. Divide by 5. Divide by 5. And I get q is greater than 2. Now, over here, the ladies were having a deep philosophical mathematical question before. And I believe the question that was brought up was something like, well, why do you want the letter on the left? And the reason you want the variable on the left is because when you go to graph, as long as the letter is on the left-hand side, you're just going to put the arrow in the same exact direction as the inequality. Okay? Now, if it's on the right-hand side, you can't do that. But with the left-hand side, it's so easy to remember. Now, if you, for some reason, solve this, that it worked out with the 2 and the q over here, well, then when you switch sides at the end, just put the q over here and the 2 and make sure if it points to the 2 there, it points to the 2 there. And then you get the ability to do the same graphing. Okay, don't go doing that. I am so tired today. All right, any questions? Easy? All right. Now, I would like you to try number 1A through E before I do numbers 1A through E. Go ahead. See if you can work it out. If you want to talk to somebody next to you, you can.
What's the compound
The
something?
problem with your shirt is you really should be smelling the underwear.
I'll rewrite.
You know what I mean? That's the spot. You can go right there. If there's no smell there, it's clean enough to wear.
So you've had an experience.
Much. Did you have any idea in college, man? You learn to wear them once the regular way, and then you turn them inside out. Take that undershirt, turn it inside out, and you get a second day's use, no problem.
You should get a mini laundry.
I'm actually really good with laundry. I am very good with it.
My sister is not.
I've been doing my own laundry since I'm your age, or younger.
So much laundry to church and it's like all he has.
All right, keep rocking it. Hold on. Yeah, you stood? Slow down, what? Go Passato? Como? That's how.
Ah,
Passato? I don't know. You can call me bad name.
I do A.
Yes, blue hair.
Thanks. It's green. My friend's dad told me it looked like my hair got flushed down the toilet.
That's wonderful.
Yeah, with that stuff that you put around the rim, yeah, it does.
So now he keeps calling me swishy. Don't do that.
Swirly? Give you a swirl.
We're flushing. For the one that says how many solutions are there to the inequality, are we talking about like integers or like everything?
Everything.
Infinite.
Yep.
What? Okay. Oh, whatever I'm thinking.
Okay, let's take a look here. Rewrite the inequality as a compound sentence. Now, look, this means that the x, behave. The x is going to be greater than 0 and the x is going to be less than 3. Both of those things are going on at the same time. Now, it looks kind of weird because the x is on the left in both cases, but can't we just, if we wanted to, switch the order here? Isn't that the same statement? X is bigger than 0, or 0 is smaller than x. Or font is smaller than Mr. Lindquist. Mr. Lindquist is bigger than font. Isn't it the same exact statement depending on how you want to look at it?
What?
Yeah.
Right?
I thought you gotta make the
Well, the reason I switched it in this case is, if I then extend this to 0 less than x, and then I include this statement, the x is less than 3, I get back to the bounded interval. Does that make sense? How you could put the two of them together into one statement? Okay, graph the inequality on a number line. Well, I have 0, I have 3. They're both open circles because there's no or equal to underneath. And as we mentioned, always try to shade above the line so there's no doubt where it is that you're shading. Okay? How many solutions are there to the inequality? How many?
A lot.
2.
Infinite. Because it's every single number between 0 and 3, including the fractions and the decimals. If it was only integers, then the answer would be 2. Okay? The only time you assume integers is if they tell you integers. If they don't tell you integral values or integers, then you just assume it's every single number on there. How many solutions are there? We just explained. What are the largest and smallest possible values for x? There is no largest possible value for x, and there is no smallest possible value for x. Every time you think you've gotten to the smallest value, say 0.1, I can just add another zip, and I can make it a little bit smaller. Likewise, if I think it's 0.9999999, or I should say 2.9999999, I could then say 2.99999999991, and it's automatically going to be bigger. If the inequality is changed to this, then what's the largest and smallest possible value? 0 is smallest, largest is 3. Good. All right, so let's see you guys write a compound inequality for this. Now, do you remember how we talked about the walk like an Egyptian?
Yeah.
Right, remember that? By the way, Jacob Dukowitz does the most incredible walk like an Egyptian dance. He has this way of moving his head one way and his arms the other way, but he does it really good. Maybe it's that you don't expect it to be really good, but it's very funny. It really is. It's hysterical.
You should practice it.
Yeah, I'm just not. Me and dancing, no. Dancing and I don't necessarily complement one another. Oh. I just, listen, God gives everybody different gifts. I've got some good gifts. Dancing would not be one of them. I have danced. I danced a 24-hour marathon once.
I know.
Raised money for breast cancer research. This is how I danced.
No wonder you last the longest.
I last the longest because I'm tough. Okay. All right. So let's just take a look at this half. What's this half's inequality over here on the left? What is that one going to be? X is less than. 1. Good. Now let's just do the right-hand half. What is that one?
3, x is greater or equal.
Greater than or equal to, because the dot is filled in. Now, because it's a walk like an Egyptian scenario, I just put an or in the middle. Because it's either less than 1, what? Or greater than or equal to 3. You clearly can't be both. Yes? 3 less than x less than 1. Listen. Other way. Okay, well, here's the thing. Now let's think this through. What number is 3 less than, and that number is also less than 1? There are none, right? Because like if you say, oh, 3 is less than 5. Great. Is 5 less than 1? No. So it can't be. When you're going to write a bounded interval, it always has to be, you have to switch the 1 and the 3. It has to be from smallest to biggest. Now, the next one is similar. Well, what do you, let's again divide this into half right along here. What do you think the first inequality is?
X is less than 2.
Good. And what do you think the next inequality is?
X is more than 2.
Greater than 2. Good. And in the middle goes the word or, because we're going in opposite directions here. And this is a little bit of a gimmicky one, because they're all around 2. Another way to write it is x is not allowed to equal 2, because it's every other number except 2. So you could write it that way as well. Okay? Now, what does that word compound mean?
Two things wrong.
2 or more, right? When you have compound problems, you have at least 2 problems. When you have a compound fracture, you have the bone broken plus it pierces the skin. What does the graph of an or look like, everybody? What's the graph of an or look like? Show me.
An or?
An or statement. Show me. That's it. Come on. Get them up. Let's go. Oh, you're a cheerleader. You have to do this. No.
Captain.
I want a new cheer.
Co-captain.
I want you to go out there like, Okay. And what's an end graph look like?
I don't know.
The end graph is the bounded interval.
This?
Like whatever, 0, 4.
It's like this?
Ooh.
Yeah, there you go. Hit yourself in the head. There's an end symbol. Oh, you mean like which way is it to the beach? That kind of thing? There you go. Superman does that? Superman does that. All right.
Yes, when she hit. Yeah,